and in between we can stop the recording and talk again, so do not worry. Okay, Astro Journeys is the program which this is based on, now joined together with the EU project STAND. I'm not going in the details of this program now. I'll show you later the websites for the details. And one part of both programs is how to use robotic telescopes. And now let's have a look at the telescopes we can use within this project. So on the screen, you see the large network of Las Cumbres observatories and the Schools Observatory. One is still missing, it's a bit outdated, the 2-meter on La Palma. So we have a network of more than a dozen telescopes where you can, free of charge, make images from. That's not live, that's to be programmed. 2 of them can be used live. That's the 2 ones in Hawaii and Australia, the 2-meter telescopes. And these are the telescopes which are in the network. But no panic. You don't have to worry which one fits best for your things. It is decided automatically when you choose your object, depending to the size and the parameters and its position. So the big ones are the 3 2-meter telescopes. You have the chance here to use the largest telescopes in the world, which are available over internet. Largest robotics telescopes you can control with your web browser. I'll get to that later. That's the 2 meters. Then we have a 1-meter network. That's much easier to get time on, and the 40 centimeter, which has a wider field, which is a more typical telescope like amateurs use it. If we look at the Faulkes Telescope North in Hawaii, just to give you the scale, you see a person here on the right. It's located on the Haleakala mountain, usually high above the clouds you see behind. Around are military telescopes with the nice signs, don't come here, we shoot you, but we have the safe one next to it. And that's how it looks from inside. Again, on the bottom left, you see the people. Just to give you the scale and also to make you aware that when you control this live, it won't move immediately when you push the button because you move 26 tons. Here you see it under construction and the mirror. It's an F10 optics and has several cameras and spectrographs. But be aware, if you have a large telescope, it has a small field of view. You see only a tenth of the moon. Moon itself you can't observe directly except with one. And but again, do not worry. For those objects which are small, the Schools Observatory automatically selects the right telescope. If I go down to the 1-meter one, almost the full moon fits in. And if we have the 40 centimeter network, it is much more. It's more than 1 degree field of view. So you can observe classic well-known objects like Orion Nebula, like large galaxies, or in the south, the Eta Carina Nebula. But for those who are not used to these cameras, be aware you do not make images just at once, like with a color camera. You make images with a black and white camera, which has filters. You see them here. It has a filter wheel. So you make red, green, and blue one after the other. And later you need the software to generate the color image. For the experienced ones, you also have the option to get hydrogen alpha in or oxygen. How that works, I can explain in the end. So that were the locations. And now I will jump into the important websites where we go now. I'll leave this on a bit longer. We have a detailed documentation about that, what I'm talking here, on the Astro Journeys website. If you go to Astro Journeys, I'll show it to you in a minute, and just type telescopes in the resources, you will find it. Second thing we go in is to the Schools Observatory, the main website we need today, in one word, schoolsobservatory.org. And finally, we talk about the image competition in Project STAND, which you find under Project STAND in oneword.eu. Again, this we will show. Maybe, Gustavo, you can type it in parallel in the chat. So that's the easy way so you all can get it. And then at the end, we talk about this image competition. So that was the overview. And here you see the Astro Journeys website. And if I go on the main homepage of Astro Journeys, and if you go then to resources, suggested resources, and just type telescope, you will find here robotic telescopes. And here is this toolkit. And if you click on the handbook, all what I'm explaining now is explained again very much in detail. So you can have an eye on that in between. You can go through it and check back later what we are all doing here in the things. Now, Schools Observatory is this website. And the first thing you need to do if you want to use these telescopes is to register, which is here right on top, this button. So if I click on it, my network is a bit slow, then you see three options: Explorer, Student, or Educator. Please, for you, always use the Educator mode, that's the teacher's mode. Students can register as well via the teachers. I will show you later. And Explorer is just a very simple account to get the idea how it's running, also made for children to have a look themselves. If you go on Register, you can here add an email address, your username, school name, your location, select who you are, and then usually when you create a new account, within minutes, you get the account. And as soon as you have an account, you can go to login. I'm now using my account. And you see your administration page on top. We click on my account here on top. So I start with the formal things because you can create the accounts for your own students. So each of your students can have his or her own account. This you see on top, create a student. And again, you define a name, a password, you define it yourself. You define the age group, which defines how many resources they will see, if they are adequate for them or not. If you go to professionals, you see everything. If you go lower, then only the more simple resources, and lots of them are available here, are visible for the student. So you can adapt it to the knowledge of your student, what they later see. You can also create a group of students at once, numbers as you like, create a lot of new accounts, and it also auto-generates passwords. When you've done that, you can go to Manage Students. And the top one, that's myself when I'm testing. So you see the student name, the password to get in, the age group you defined, and what is then nice if you want to check what they did as their homework. You go here on Masquerade, and then you are the student and see exactly, I'll show later under my observations on the one, on what they did and what they did observe. You go back to Unmasquerade and you are yourself again. I'll just show that again, my account, Manage Students, Masquerade, and then you can shift over and see what your students did. They don't see your account, but you can see theirs. So that's the general thing, how to get the accounts and how to get started. Any questions for this so far? If all is silent, then we can go to the more interesting things. That's observing. Here are two things you should have a look at. You see the point go observing and things to do. Go observing, be aware that you can click on the things itself, not on the points below, brings you to the interface with the objects. And partly you can see this even if you're not logged in, especially things to do. And things to do is a large list of objects, of things you can make with your students. You have ways to look for the topics you're interested in. And each of them has detailed descriptions how to do the things. It's many things. You always see the age, the time you need for it. For example, keep watch on asteroids explained in detail. So lots and lots of resources which can give you ideas. So I recommend that for your lectures, you have a closer look here, what may be fitting for you, and you save a lot of time creating materials. So, and what you see here is depending to the age you set for the students. As you can see here by age, if you select students 11 to 14, they won't see the projects for the older ones, which they can't do yet. But now go observing. That's, of course, the fun bit. We have two ways to observe. Way one, which I would recommend to you in the beginning, is an offline mode. And the other option is live observing, where you need a bit more experience. So let's start with the offline programming. So you see now here several options. For the beginners, I would recommend the first part here, galaxies, moon, planets, and stars. For more advanced users, we have advanced observing and special objects. Because the top ones are really simple. You can't do something wrong. You can't harm any of the telescopes, which is the good news. So let's have a look. Maybe you want to observe a galaxy. So I click on this. And now I showed you that these cameras are usually black and white, and you have to decide which filter you use. That's why you observe a galaxy as a black and white image. And on the right, you see 3-color galaxy, which means you get a color image. But you have to adapt it yourself out of the 3 images. So I start simple with a black and white, let's say black and white image of a galaxy. And the next question you usually have is which objects are visible at the moment? Which can I see or which ones are behind the sun? And again, in this mode, you do not have to worry because the objects selected here are all nicely visible and ready to observe. So no reason to worry. So what's visible here can be done immediately. On the right, you see conditions to observe it. This has mainly to do with the moon. Bright moon means faint galaxies are not so high in contrast. The moon's light disturbs, so the darker here, the better the time period to observe. If you're not sure what this object is like, there's the information button. If you click on it, you have detailed facts about the galaxy. So, for example, your students can make a fact sheet out of it. And there's a spiral galaxies, cluster, and so on. How it's visible from which of the telescopes. And let's say we want to observe these objects. Then I click on the name itself. And then it suggests me the exposure time and the filter on its own. You do not have to worry, how long do I have to expose it? How does that work? It is all pre-selected. All you have to do is check the data to see it and then just say submit observation. It explains in detail what will happen now that it is now sent to a telescope. And now we have an automatic scheduler, which checks which telescope has good conditions, where do we have clear sky, and usually within 1 week until your next lecture next week, the image should be available. To see how it works, you go back to Go Observing and the point below My Observations. And you see here on top, a galaxy submitted right now, date of submission. And if you did something wrong, I don't want to waste observatory time now, you could also delete it here, which I will do now, because of course I don't want to waste time. So if you made a mistake, no worries, just take it out. So, and here you see also the images you already did. We come to that in a few minutes. Now, Go Observing has more opportunities. Now, within galaxies, we can also say 3-color images. And now we're at the point where it makes pictures in red, green, and blue. If I choose an object, you now see, it makes, in this case, even 4 images. Well, let's look for another one. So it makes the color images on its own, red, green, and blue. The same thing happens. You say submit, and then you get the 3 images. If I go back and go to stars, stars is a bit misleading because we also have gas nebulas here. So under stars, it's all the things. We also have programs. You see, if you want to have objects where stars are born, can choose where the death of a star happens. It's again explained in detail what that means, and then it will suggest you a fitting object. So lots of things where you can explore. And again, I go now in the 3-color stars and nebula. And now again, you have objects which are visible right now and where you are ready to make them. And it will make it on automatic. So that's the basic way where you do not have to worry at all. But maybe you are experienced and you want to do more than that. Well, moon and planets works the same way, by the way. And when you want to do more, then we come to these fields, advanced observing. So if I click on that, now you have to think, because you see all objects which are in the list, which are ready to be observed by the telescope. I again select just galaxy or nebula. It explains again what that is. And now you can select a lot more. How long are you willing to wait for the image? The longer time you give the schedulers, the larger are the chances you get it. My recommendation is 1 week. Then it usually works with one of the telescopes, and you have it in the next lecture next week when you're with the students again. I say continue. And then I have a list of lots and lots of objects suitable to observe. But here you need to be careful. That's also objects which are right now behind the sun. So you need to go to your own planetarium software before, like Stellarium, which is free, and check where these objects are, if they are visible right now. They are listed after the coordinates, starting with 0, with direct ascendation. And you see we have hundreds of objects here listed in order. And the other way is you can also manually enter here a name and it will find it. So this is the way where you can choose a lot more, but you have to decide more. Let's say we want M27, the Dumpel Nebula. Now you can choose your exposure time. Do I want 30 seconds, 60 seconds, 90, 120? 120 gives a very good quality image. And now you can choose even more. I had the question before for other filters, not just red, green, and blue. You see here's a lot more. And this I need to explain. R means red. V is a strange name of astronomers for visual, which is in reality green, but it's also listed here. And B is blue. So, and in addition, you have ultraviolet, infrared, and hydrogen alpha. That's a narrowband filter exactly for the red colors of gas nebulas. So you can choose your filters and what you want, but you need a bit of experience with that. So my recommendation is to do this as the second thing. And then you can choose even more. Sky brightness. Is it okay? Is this object bright so I can do it when the moon is there? Or do I need dark conditions without the moon? Of course, the less you allow, the lower the chance that the image is done. You can check your seeing conditions. Do I want a perfectly clear image? Or would I accept if the stars are a bit bigger due to poor sky quality? So you can choose. And then it again shows you an image, how it should look like from a survey, your definitions, and then you click simply on Submit. So that's the advanced way. Just go on observing again. Then in addition, we have special things here, investigations. And this changes from time to time, depending what objects we have. For example, at the moment we hunt near-Earth objects. This can be done here. So we have several programs which change from time to time. So have a look what's right here explained right now. And yeah, choose what you like. Also, there's a huge archive. We have the interstellar comet, help functions, very detailed help, how to use Go Observing, and back to my observations. So that is the way how to program images. My method is defining it in the first week with the students. Which object do I want to observe? Program them, and then the next week I download them and work on the images. Yeah, the other interesting thing is live observing. And this has a completely different interface. The reason is that this comes from the other part of this group, from Schools Observatory in the US. And this is a bit more complicated. You need to know a bit more. So I would recommend to do this a bit later when you started with the other way. So if I go here on live observing, you see to the right, live observing guidance. We go to that in a minute, and suggested targets. Careful, live observing is not on the subpoint. If you go on the main thing here, you get on the page. And this is where you can book one of the 2-meter size telescopes in Hawaii and Australia, the original Faulkes telescopes. And they're available one slot in the morning, one in the afternoon. You can go here to book a live observing slot. And now be careful. You all come from different time zones. And that's why we have listed all the times in Universal Time in UTC and Greenwich Time. So be careful with your own time zone here. And then you can see every day, almost every day except Sundays, we have a 30-minute slot, one in the morning, one in the afternoon. The morning slots are always the Faulkes Telescope South in Siding Spring for the southern sky, and the afternoon slots, Faulkes Telescope North in Hawaii. And you see it's already well booked. If you have special events, I can do something in advance to help you. But here you can see next chance would be for example, 1st of May. There you could say book, and then you book your own slot. Then you will get a confirmation email that this is booked. Please note the time and date for yourself to be safe. And 1 to 2 days before, you will receive an email with a so-called observing token. And how this live observing works, we can go to live observing guidance. And this is described extremely in detail here. So just on the day before, go on it and you will see all the points. I will go quickly through it as this is a long thing. So you book your slot, you receive a nice and long token, very easy to copy and paste, that's the only way. And there's a link to the website which you will receive, and then you enter the token, and then for 30 minutes the telescope is yours. Then you type in the token here. No, you copy and paste it. And then you start the real-time interface. As I said, it's all explained here in detail. It shows that the telescope is available. If something is red, you have bad weather or technical issues, so this must be green if everything works. Of course, you have the risk with weather and technical issues with live things, so always please have a plan B. Even in Hawaii, we have bad nights, and especially in winter, so be aware. Then you can enter target names and the coordinates. I recommend that you plan this in advance and you note down the coordinates. My way is that I select with the students the objects before, and each student notes target name and coordinates, and one student after the other comes to the computer and does it. Then you see the last image from before, and yeah, there you can, as I said, select the targets. If you're not trained, there's also a list. I'll come to that in a minute. And then you have to decide about your exposure time. So you need a bit of experience. How long do I need to expose these images? Guidance is what you see in the offline queue, what I showed you before. And if you're not sure, you go to a list of objects If you had no time to prepare it, again, it suggests you also the exposure times. And then it takes the images. If all is green, it is working. And finally, if you say, here go, the telescope moves, you may see it moving on a webcam. Depends if it works. It shows you how much time is left. And finally, you receive the images. You click on the link and download them for later processing. Don't forget it at the end. Within 15 minutes after your slot, all the processed images are there. For those who are deep in the things, you do not have to worry about flat field or dark frames. It's automatically reduced. Yeah, and that is how live observing runs. As I said, look here under Go Observing Live, the guidance, and also here's a list of suggested targets if you're not so uh, trained with it. So all is available here.
To know what time to take for the photography,
Mhm.
the plan could be to go to the archive
Exactly.
and try to find the time already, because with half an hour and with the students it's very hard. The mind are
Yes.
a bit small. It's hard
Yes,
to imagine how long time we have to choose.
exactly. That's where you can go on the archive here, archive of observations, select the objects, let's get something, and then check it out.
Okay.
So then you see here you see already how that was exposed, what others did, and you can click on all the images and see how that looked like. Yeah, that's why I come now anyway to how to process the images. So that's my recommendation. Prepare it well in advance. Go in the archive, check how others did it, and then you see
Okay.
was that good or bad.
Okay.
And I can display one of the images here. Takes a while, and then you um, see what is best. Here, display scaling. I'll explain it a bit later. So you see, was good, was bad.
Okay.
Just show it again. Um, Home, archive of observations, and all observations all schools do are available here. So you can and you can also select manually, so you can really go through. And even so, if you have not images yet, go in here, look for other images, download them, work on them. You may even, if you look for supernovas and other galaxies, look for old images from that galaxy to compare. So it's very well worth having a closer look at this archive, also with your students. Okay. Then I will continue. Now we want to, of course, check our own images. I go back to my observations. So that were my ones here I had for testing. So let's say start with the black and white image. And now you can see here view image. And then it asks you how do you want to get it. There's a software called Astrolab, which is included here at the Schools Observatory on the web interface. So no need to download any software and install it. You can do it right here. Alternatively, you can, if you're experienced, if you have your own software, download the FITS file, what's the name of these raw images directly, and process it in your own software, especially if you have an astronomy club with you who has the software, and or get pictures automatically made. I'd start with this button, get pictures made from data. Then it asks you how much detail you want. You look what looks best, and super quick, you have an image. It's just the downloading time because it has a lot of resolution. And there you see this galaxy and lots of detail. So that works within a minute. Yeah. To do a bit more, if I go back, you can go here in Astrolab, which is the software to process it yourself. So again, excuse the delay here. My internet today is not the fastest, but do not be surprised that you see nothing in the first moment. Don't throw the image away. It doesn't mean it is bad. Why? Astronomical images have values for the grayscale of 16 bits, so 64,000 steps in brightness. But the eye can't see so many, and no screen can show it. You have to first go to display and scaling, display scaling, and then you can choose minimum and maximum value or go to most detail. I'll ask them to open this window on automatic, so because people always believe there's nothing there, because if I click to most detail, you already see the object. If I go back to normal, then you have these bars, and if I scroll it down, then you see how the galaxy comes out. And you see also in the window on the left details, and you can work with the image. There are many functions, zooming the image in here to see it a bit more. If we would have make a 3-color image, we could make it colored here. We can make false colors to see things a bit better. Oh, that was a bad one, headache one. Yeah, so you can choose. You are able to measure sizes and brightnesses. If I add a line, yeah, so it shows you if you want to have a diameter or whatever, you can make calculations and it is all explained. So just play with this and you see lots of functions, and the number of functions will increase within the next 2 years. And soon we will have a coordinate measurement for asteroids, for example. So here you can work on the images, open an image, download it, see the FITS header, how it was done. So all the basic things you want to play with. Yeah, well, that is Astrolab. Maybe let's make it again with a different image. Again, display, help on displaying. You have detailed information how to do it, how to process it, how it works. So if you click on the things, lots and lots of help functions are included. So again, my observations. Let's say we want to have a look at what did I take? Let's say this one. So, and there you see the different filters where you could go on and then add them to Astrolab. And then as we are running a bit out of time, I will not go too deep now. And then you can go to make your color image and adjust it the same way as I did it before. So just don't do it now as these images are huge and my network is a bit slow. But that's in general the way how to process. I just show again my observations. Choose an object. You see the data here, how it was taken. And then I go on View Images. And then the fast way, get the pictures made from this data on automatic. And you have the quick results. Yeah, that's how in general this is working. Yes, if you need more than what's possible here, maybe Gustavo, you can also come in. We have Salsa J, a software which we are building up for Astro Journeys, which will soon be available. It's in the process, where you can do exactly this.
Yes, I was going to mention Salsa J, which has been around for quite some time. But there are two different things, right? One is to process the data, which is reading the raw files or the FITS files. And then there's the post-processing, which is making the color images more nice. And that can be done in image software, like Photoshop is the most well-known. But you also have GIMP, as Walter just mentioned in the chat, which is free. And also there's a version from ESO, from the European Southern Observatory, which is called FITS Liberator, which also allows to do some processing. I will put the links on the chat, and I hope this helps.
Yeah, and just show you what to do. You go to View Image, and then you download FITS image. And then you can process it in free software. And bit by bit, we will have it on the Astro Journeys website with all the descriptions. And we are right now working on an online version available of Salsa J. So I hope we have it for the next school year available. And in between, other programs also available via the Astro Journey website. You get the links how to work with them. And yeah, I can only recommend test it out. There is no limit with the number of objects you can observe within the school observatories, but there's a limit how many at once. So you can observe you can program up to 3 objects. Each of your students can as well. Just be aware that if somebody has already observed a lot, he will be ranked a bit lower. So new beginners get priority with images. Those who have made the 20th image have to wait a bit longer. You can generate the accounts for your students. They can observe offline. They cannot use the online interface, the live interface. That's only the teachers, as it's more complicated. Yeah, and then I can only recommend test it out, play with it, and if you have questions, contact us via Project Astro Journeys or Project Stand. Yeah, and now I'm available for all kind of remaining questions.
I have a question about the cameras used by the telescope for the photography, because when you need to do astrometry for composing color images, you need to do astrometry, and then the program asks for characteristic of camera, like resolution, focal, and all of that, and diameter.
Yeah.
And I tried to find for the Liverpool telescope, and it's not so easy to find it. So I would like to know where to go to find this kind of information for each telescope.
Okay,
Or
Liverpool
Muscat as well, I tried to find, and I didn't really found.
Yeah, there you still need to go on the old way to the LCO interface. That's lco.global, because it's Las Cumbres Observatory running them, except the Liverpool telescope. There the data should be on the page. I will ask the team why it's not there. And here, when I go to lco.global, that's a more complicated interface. If you make the live observations, you will end up there. There you find observatory information. And here it's everything about the instruments. There you have the Muscat 1 meter. There you have all the data.
Okay.
lco.global. I'll also copy it in here. That's one of the challenges getting these projects joined together, but that's not yet on the TSO side.
Okay,
So lots of information here. And for the more experienced users, if you need, for example, for your things more than what's available with the Schools Observatory, we can talk about an account here at LCO, but there you need experience.
There's a question also by Walter here in the chat.
Yes,
If it's
let's
possible
make that first, yeah.
for the exoplanet transits for the Exoclock project. And
yes, we need, with LCO, we can. You need an account with the Schools Observatory, and then I need the information why, in addition, you need the other telescope, and then we can arrange an LCO account and offer 1 or 2 hours observation time.
very well.
Just on Salsa J, it's possible to compose in color images?
It is. It has one of the functions is to make a 3-color image. You just select which filter you want red, which one you want green, and which one you want in blue.
So it's not with spatial filters.
Well, it depends what you define for red. You can define 2 red, for example, and one special filter is it, or exchange red to the hydrogen alpha.
Yeah.
Yes, this kind of very specific processing you are asking is best done in like GIMP, because then you can have assign the exact color you want for each one of the images and then
Yes.
superpose. I recommend you visit the link for the Fits Liberator, because it goes in detail on how you can combine this later. It uses Photoshop, but GIMP is the same thing. It's the same logic.
Yes, and it's free. Change, it even can manage as fits images in the meantime. So you can even get your fits images in, define one as red, one as blue, one as green, one as something in between.
This is the most direct way to do that. Yeah, but Salsa J can do things, but the images must be same dimension. They must be perfectly aligned. So it takes some effort, but I think it's worth it. Well, so if there are no more questions, I'd like to thank our speaker, Lothar, and thank everyone that is attending this webinar. Stay tuned for the next webinars. We'll have a new webinar next month, probably, on pedagogy and inclusion. So if you are sign our newsletter, follow us on social media, and you will be alerted when we have new opportunities. And please do join the competition, the image competition. We want many beautiful pictures made by students all over the world.
And I just added my email address, kurtze@ftp-Europlanet.eu, so you can contact me directly. And I'll put some information together about image processing separately then on request.
Okay. Thank you very much.
Okay.
Thank you.
That's a wrap, Emmanuel.
Thank you.
Thank you, Gustavo.
Bye-bye.
Lothar.